PTI. We're going to do a maintenance video on the GL3300 nitrogen laser, and this needs to be done periodically to to keep it right up to specifications. About every 2 weeks or something like that, depending on the usage. If it's used heavily, every 1 to 2 weeks, you should open it up, take the spark gaps apart, and clean them, and then adjust them afterwards. So the first thing to do is to make sure that the power is turned off with the key switch here, and we're also going to turn the gas pressure down. Okay, now this regulator has a separate shutoff valve here, but some people may not have this. So what you can do instead of that is just turn the pressure right down to 0 and let it bleed off, having some gas flow set on the nitrogen laser. Just turn it all the way down. That way we're not going to have any pressure no matter what happens. So we just take the screws out of the lid here so we can hinge it open and get inside. So now you just open the lid. And now we'll want to take this RF shield off here. Now, you should always make sure that all the capacitors on the laser head have been discharged. So you can just put a screwdriver down onto the chassis and touch it over to the laser head and just make sure that there's no charge left in those capacitors. And now, to be on the safe side, just unplug the laser so that you won't get any shock from anything else. So the first thing we'll do here is to take the large spark gap off. So to get at it easier, you can unplug the bleeding resistor just to get it out of the way, and then just with a 9/64 Allen key you can take the 4 screws off that hold the spark gap on. Okay, and now we can just pull the entire spark gap right out of the back of the head. Make sure that the pressure is off, because we're going to take these screws out of here, and if there's any pressure it'll blow this insulator out. Okay, now we can set those screws aside and use the screws that held the main spark gap onto the head. Just put 2 of those in and screw them in a couple of turns so that there's lots of space under the head, but make sure that there is thread going into the aluminum housing. So then we're going to apply some pressure and blow this insulator out, but the screw heads will keep it from flying out totally. Okay, so now we can just gradually turn the pressure up. So now we've turned the pressure back down to 0 again, so that we can now release these screws and pull the insulator out of the main housing. There it is. Okay, so there's the inside of that spark gap. And you can see it is dirty. It's not really dirty, but this one is only run for about a week or so. So we can clean this all up, and that'll change how it behaves. So you can start with a dry Kim wipe and just wipe the bulk of the powder off. You'll be able to see that there's a fair bit of black powder there. Now you'll notice that down inside here there's a black ring around the electrode. That's dry graphite. It's okay to wipe that with a dry Kim wipe. It won't hurt it. But don't touch it with methanol, because it will remove that, and that's an important part of the spark gap operation. So now we can use some methanol and a clean Kim wipe, and wear gloves for this, and just carefully go around and clean the plastic part, you don't really need to clean the O-ring itself. Just clean the plastic part here. And down inside there, but be careful not to touch the graphite with the methanol. And we can also clean the electrode tip. I'm just going to spin that around and you see we'll get some dirt off of that. And again, you want to make sure that you don't go down so far that you touch the graphite with methanol and Kim white. And you can clean the interior of the main housing here, again with a dry Kim white to start with, and then later we'll do it with methanol. And here we can use the methanol and Kim white for the inside of this housing. Okay, next we're going to disassemble SG1, the smaller spark gap here, and just have a look at the inside of it and clean it up as well. And we'll be doing an adjustment on the trigger pin most likely. So, remove the grid cap and undo the 4 screws. Just undo them a little bit at a time in a cross pattern so that the cap doesn't get all tilted around on angles, because we don't want the trigger pin to be touching the aluminum housing there, or the brass housing rather. Okay, and then just take that right off, and there's the trigger pin right in the center there. Now we can remove the housing from SG1, and you can just grab a hold of both the hose connectors here and wiggle it around a bit as you pull out, because it has an O-ring seal there, so there will be some resistance. And once you have that off, then you can just turn it around and have a look at the inside, and that looks like it's been running quite nicely. It hasn't been arcing around to different places, it's just arcing to the edge of the hole. But we need to clean the interior of all these parts. Again, the same thing applies. Use a dry Kim white to start with, and then methanol on a Kim white after that. Okay, so we can remove this O-ring because we can later on check the spacing between this trigger pin and the main housing. First of all, we'll just clean the powder off. And we can do the same thing with this Teflon insulator and the adjustable electrode in here. You just bunch the Kim wipe up and put it right inside and just spin it around. Again, to get just the bulk of the powder out of there, you can just blow some of that out, and then do the same thing with the housing. Get this outside part and the interior. Okay, so now we can just go over all the same parts again with methanol and Kim wipe. Let's make sure that it's as clean as we can get it. So now what we'll do is measure the trigger pin. We want to see how far the trigger pin extends beyond the surface of the plastic. That should be 175 thou, so we can use some vernier calipers and measure how far that is down there. and that's 153 thou. So we have to make that pin come out a little bit further to come up to 175 thou. To do that, what we can do is take a pair of pliers and unscrew the brass knob out of the plastic cap here. And there's a small set screw in the brass knob, and you can loosen that, and then the trigger pin can be moved, and you can see that there's an O-ring there, so you can judge how far you need to move. When we move it, the O-ring will move along with it. So we'll just guess and see how far that is, and then tighten the set screw back down. And then screw it back into the plastic cap and tighten it with a pair of pliers. You have to crush that O-ring down, that makes a seal for the gas. And then do another measurement. And that's 165 thou now. So it needs to come out about another 10 thou. So you can just repeat this again, try and judge how far the O-ring moves, get an idea how much 10 thou is, move it that amount, and tighten it down and reassemble it. Okay, so there's 175 thou. I've measured this, I have it adjusted to the right place, and we can just convert that, and it's 4.45 millimeters. So after touching these parts with your fingers to adjust the pin, this should be cleaned with methanol once again, and then it's ready to go back together. Now we can put the large spark gap back together, and we'll do it first because when you try to push this in, you get a piston effect, and if the other spark gap is already assembled, it makes it a little more difficult to get this part to go in. So if you rotate it a little as you push on it, it'll get the O-ring started in, and then line the holes up by eye. Then grab it like this, and just with your left and right hand just wiggle it down in there, and there it is. Now you can see that the holes have gone out of alignment a little bit, so you can just take, say, a 7/64 Allen wrench and put it in the hole and just tweak it around a bit until the holes look like they're lined up. And then we can just put all the screws back in and tighten those down. Once again, you want to use a cross pattern as you tighten these down so that it puts even load on all of them. And then just a little bit more. You don't have to put a whole lot of torque on this. You don't want to distort the plastic insulator. That's it. Now we're ready to reinstall it. And just carefully slide it into the back of the laser head and these 4 screws back in. Here you want to use a fair bit of torque to make sure that we have good contact between the back of the laser head and the spark gap housing. And make sure that you plug the bleeding resistor back in all the way until it stops. Now we'll reassemble the SG1. First of all, remove this grid cap here and check to see that the brass knob is as tight as you can get it. And there, we've got some, it was loosened off a little bit. And the reason for that is that the Teflon tends to change size a little bit over time. So every time you do this, you should go in and check the tightness of that, because it's making an electrical connection between this grid cap and the main electrode. So once that's done, you can plug that back on and then reinsert the brass housing, and here you'll have to wiggle this around a little bit to get over the O-ring, and make sure that it's pushed right up against the bracket. Then place the O-ring back in this, and 4 screws. You can just load them all in here before you put it on the housing. Set it so that this set screw here is pointing away from the laser head. Screwdriver, and carefully place it back on to the housing, making sure not to scratch the housing with the trigger pin. So you can tell when it's on there. You should be able to rotate it around a little bit, and it's just sliding on the O-ring right now. And then you can start all 4 screws. Just come up until you just touch the housing, and do this in a cross pattern again. Get it started. Okay, now that they're all touching, there's a little bit of load on the O-ring, and you can still move it around a bit and just see that the screws all look like they're square to the bracket and that everything's lined up. Then tighten each screw a little bit at a time in the cross pattern to evenly pull this down and crush the O-ring down. Okay, and eventually it'll just come to a stop. And that's tight enough. Then plug this grid cap back on, and that's it. Now you want to make sure that these fittings are sitting on a slight angle like that. That makes enough clearance for this bottom screw to clear the right hand fitting here. If you have this straight up and down, then this fitting will interfere with the screw, so it needs to be just cranked around a little bit like that. Now we can put the aluminum housing back on the laser head. This will shield it for any sensitive electronics you have around, because there is a fair bit of RFI and EMI that comes from that, but it's quite well shielded when that's on. Now we'll turn the gas pressure back up to 80 psi on the regulator. Okay, so there we are at 80 psi. And check on these gauges here to make sure that the SG2 is 80 psi and SG1 should be somewhere between 45 and 47. 47 is usually best if you're going to be running at higher rep rate. And at this point you want to check the gas flow. We're going to run it at about 3 Hertz, fairly slow, and at that rep rate this should be set to 25. So if you turn it all the way in until it stops, that's 0, then each revolution is 25 units. So there's 25 right there. And that's what we're running at for this high voltage breakdown test. So plug the laser back in, turn the voltage right down to 0, just turn the knob all the way until it stops. We'll have it in internal mode, and this set somewhere in that kind of position there. That should be close to 3 Hertz or 2 or 3, what we want to run at. So to get it to run with the lid open, obviously don't go anywhere near any of the electrical components inside there. And when we want to run it like this, we have to defeat these switches so that now we can switch it on. If these switches are in this position, it won't start. When the lid comes down, it pushes the switches to be in this position and it will start, but it won't start like this, so we have to pull them up. Then we can switch it on. And since we've had the spark gaps apart, they'll be full of air, so we need to purge the spark gaps quite a bit here, probably for about 10 or 15 seconds. So just hit the purge button. And then recheck the pressures, because they can change a little bit when you purge it. Now we'll slowly turn the voltage up. And you can hear the small spark gap starting to fire there by itself. It's a little bit fast, we'll turn it down a bit. And it's holding off to almost 12 kilovolts. Ideally, this should be set so that it starts to fire somewhere around 10 kilovolts, and 11, but not. It should run reliably at 12 kilovolts. So as you keep turning it up, the laser should fire around 15 kilovolts, and that's what it's doing right now. And it's running reliably at 15 kilovolts. So that spark gap likely doesn't need to be adjusted at all, but the smaller spark gap needs to be made a little bit narrower so that it starts to fire at a lower voltage. So switch the laser off again, and we're going to give it a few seconds for the capacitors to discharge before we pull the can off, and then we'll check the capacitors after we have it off. So the can, and we place the screwdriver in and short the head out. Okay, after shorting the head out, unplug the unit again, and now we can go in and adjust the SG1. Remove the grid cap and put an Allen wrench in the hole on this black lock nut, and you can loosen that. And then use a pair of pliers with larger teeth, and you can grab onto these ribs here with the pliers. And this is a normal right hand thread, so you would just turn it like so to make the gap narrower. That should probably be enough to reduce the breakdown voltage. Tighten the lock nut back down, plug the cap back on, and then we'll place the can back on and try the breakdown test again. Now it's starting to fire at around about 11 kilovolts, and the larger one is still at about 15. So that needs to be adjusted a little bit further just to bring it down so that it starts around 10 kilovolts. So what we can do now is I'll show you. In this case, we don't have to adjust the large spark gap, but I'll show you how that's done just in case. If it's holding off to around 16 or 17 kilovolts, then it should be adjusted so that it fires at 15. So once again, we can remove the can. Short the head out, and we'll just unplug it. To adjust the SG2, it's quite simple. All you need is an Allen key, and you can put it in the holes in this brass knob sticking out the back. So this is the adjustable electrode, and you can just turn it in this direction to make it narrower, and that'll reduce the breakdown voltage for this spark gap. So I'm just going to put it back to where it was before. This spark gap still needs to be adjusted a little bit more, and once that's done to fire at 10 kilovolts, then everything should be fine. So all you need to do is keep trying the adjustments here until SG1 fires somewhere between 10 and 12 kilovolts. It should fire reliably at 12 kilovolts, and SG2 fires at 15 kilovolts. And then the adjustments are all finished. Replace the can, put all the screws back in, swing the hinge lid down, put those screws back in, and you're ready to go.